This episode of Unconventional Engineering is brought to you by Metrics. Metrics, transforming the industry together. Greetings, everybody, and welcome back to ASME's podcast, Unconventional Engineering. I'm your host, Roy Firestone, here with my co-host, ASME's Executive Director and CEO, Tom Costabile. And today we're also joined by a very special guest host, ASME President Mahatesh Hiremouth. Tom, it's good to see you, and Mahatesh, welcome to the show as well.
Roy, hello again, and it's good to be with you.
Thanks for having me, Roy and Tom. I look forward to a very fascinating discussion today.
Oh, I think it's going to be terrific. Folks, we're very pleased to welcome to today's podcast not one, but two guests from the Los Alamos National Laboratory who are exploring life on Mars. Tony Nelson has been a research and development engineer in the Intelligence and Space Research Division, where he's designed and operated a variety of spaceflight instruments, including ChemCam on the Mars Science Laboratory, Curiosity rover, and the Mars 2020 SuperCam body unit. And also Dr. Nina Lanza. She is the team lead for space and planetary exploration in space and remote sensing, where she is also the principal investigator of the ChemCam instrument on board the Mars Science Laboratory, Curiosity rover, and a science team member for the SuperCam instrument on board the Mars 2020 Perseverance rover. These are really brilliant people, and we are thrilled to have them. Nina and Tony, welcome to Unconventional Engineering.
Well, thanks so much. We're so happy to be here.
Yeah. Well, it's good. It's really going to be cool to talk, because I've always dreamed about talking about Mars on television shows over the years, as since I was a little kid. So this is going to be a lot of fun. Let me start for you first, Tony. What first interested you in working in building space rovers?
Well, I mean, I think the allure of NASA missions for any engineer is really powerful. You know, a lot of us grew up watching NASA missions. For me, in the 80s with the space shuttle missions and the space station. And then in the late 90s, when the rovers started to come online, that was very inspiring. So when I was offered a chance to work on initially ChemCam, I just accepted immediately because it sounded like a lot of fun.
And Nina, how did you get into planetary research?
Well, I've loved space ever since I was a kid, just like Tony. And I can remember back, my parents took me to an outreach event where I got to look at Halley's Comet through a telescope. So I was only 7 years old. And it was the first time that I realized that space was out there, that it wasn't just a dome covering, Earth, that there was actually things out there. And I knew there was nothing more exciting to me than figuring out what was out there. Now, of course, when I was 7, I had no idea how you would do that. So I pursued studies in astronomy as an undergraduate before I realized that, to study things like planets that are made out of rocks, you need to know something about rocks. So I ended up becoming a geologist so I could study other planets.
Interesting. Well, Roy, it's truly an honor for me to be here talking literally to a couple of rocket scientists. And we have 3 of them. Mahatesh, in his day job, that's what he does as well. So it's a special podcast for me. So Nina and Tony, you've worked together for quite some time. How does your work, Nina, influence the work of Tony? And Tony, how does your work influence Nina?
Well, that's a great question. I think that people often think that geology and engineering are somehow completely separate, and maybe they can be, but actually we have to work really closely together to be able to do a mission that not only physically works, but also that we get science from. So, I'm a scientist, and so I'm not the person who is designing and building these instruments, but I have to understand them. So I have to work with someone like Tony, who knows what I'm trying to do and can help me realize that in a physical way.
Yeah, that's right. Nina and other scientists will come up with, sort of like, what do we want to investigate, on Mars, for example. And she'll be working with the engineers to develop an instrument that can do what she wants. And it's a pretty exciting process because you're really starting from scratch, taking the things you've learned on other missions, but really going at it from a pure point of view. It's great.
So Tony, following to that, how do you first approach building a rover?
Yeah, well, I mean, we have a huge list of requirements. So those will be things like, the science that we hope to get out of it and quantifying that. And from that, we can start to sketch out ideas of how in our case, this SuperCam instrument might function. And keep in mind, we're doing that with teams across the world, including NASA at JPL in California, and also our partners in France at a number of institutions there. So we're really putting this thing together. It's quite a complicated system, and because of that, we have a number of systems engineers that help us with that design process. So that's really key. So a lot of work goes on in the early stages to define the system.
And maybe I can jump in here too. So NASA also gives us some requirements right from the get-go. The sky is not the limit for these rovers. We have to design instruments that not only do certain things to acquire certain types of data, but also that fit into certain payload spaces, because they know what the spacecraft is generally going to look like. So for Curiosity and for Perseverance, which are twins, actually, they look very, very similar. We knew that there was a space on the top of the mast that we would occupy. So we're limited in dimensions, in mass, and things like that, so that we know that we have to design something that does the science we want, but within certain constraints. So I think that's actually probably very challenging. Of course, I'm saying this as somebody who doesn't do that, but I feel like it's hard to put that all together, get the science and in the package we want it.
Yeah, when you think of the words curiosity and perseverance, you associate them with the NASA rovers. Also, those two words really fit your own career, your curiosity in, planetary exploration, and then your perseverance in pursuing your own career. They seem to fit right well there. So my question is really, what have you learned so far from your study of Mars, and where you are, and what you find most exciting about it?
Thank you. You're right. I think curiosity is exactly what drives us. It's not only just the name of our rover, but it's really the motivation for why we're doing space exploration in general. And of course, we must persevere to be able to make that happen. But it's totally worth it. We've learned so much about Mars. It's hard to pick out just, a few things, but I'll try. The first big thing that we've learned just from all of our studies of Mars is that Mars was a really habitable place. So that's a place that could sustain life as we currently understand it. And not just for a short period of time. Mars was habitable for a long period of time. So that doesn't mean that it was inhabited, but it opens up that possibility. So we spent a lot of time trying to understand habitability on Mars. We found that. And the next thing we're trying to learn is now, were there ever Martians? And we don't think they were macroscopic. We don't see any evidence for things like dinosaurs or trees, right? But we're thinking microbial life. And that's something that's very hard to understand, even with all the tools we have on Earth. Studying ancient life is still very challenging, even here on Earth. But we're doing that on Mars. And part of the way we're doing that now, I'm so excited about this. Part of our mission on Perseverance is actually to take samples from Mars and then return them to Earth for the very first time. And so we can take these samples of materials that we know were formed in a habitable environment and then take a look and see if there were any evidence for microbes in them. So, it's so exciting. I don't know what we're going to find, but I think that it's very possible that we could find something exciting. So we've seen, we can see in these rocks, not only were they formed in watery environments, but they actually had a lot of organic materials still preserved in them, which is amazing considering how old they are. They're 3 billion years old. They've been sitting on the surface of Mars for a really long time. So that tells you that this was an environment in which all the raw ingredients for life existed. So the next step is to actually take a look at these rocks in our laboratory and figure out, is there any signs of life in them?
My role on these missions after we've designed and built these instruments is to perform what we call operations, or essentially prepare the commands and analyze data from our instruments. And so we're learning all the time how our electronics, how our sensors, our spectrometers behave in a Martian environment, and how to design them better. So there's a lot to learn there. And it's, of course, exciting as an engineer to be involved with targeting these samples, helping to query the area around the rover and try to select the best possible samples, because that'll be an enormously exciting mission to bring those samples back.
What a typical day looks like? Is it all about looking at data coming from Mars, and then if there is something exciting, how do you guys get together and release that information to the community at large?
There's actually a process to release the data that NASA has, and so every number of months, we have some of our team members put together all of our instrument data and make sure it's in a format that's usable by the community. So that's a process that happens periodically. But to answer your first question about what a typical day looks like, we're downlinking data at the start of the day, and we're looking at that immediately. So we're checking things like making sure that our instrument is healthy, that it's doing the things we expected it to on the previous day, and then that informs the kind of things we can uplink the next day, the kind of commands that we can send. The pictures we get back will tell the geologists like Nina what kind of targets we should be targeting, and then the scientists will work with the engineers to make that happen.
And it's worth noting, too, that sometimes scientists don't have any idea how the instrument works, so they want us to do something crazy, right? And so people like Tony have to be like, we need to take care of our instrument and not command it this way. It's actually amazing how we can use our instrument in ways we never anticipated. I think a good example of that is we use our spectrometers in a passive mode, and we had never planned on doing that with ChemCam. That was supposed to be just active with our laser spectroscopy. But now we had some scientists who thought, well, why don't we just do some collects that are passive and see what we can see? And it turns out we can actually see some reflectance spectroscopy that tells us more about the mineralogy of the materials. And so that's something that the engineers had to develop for the scientists who wanted to get some data, and we actually have the capability to do that in a safe way. That's not something that we started doing, but that to me is, again, a really great interplay between, the science and the engineering. It's not something that happens just during the construction of a rover, but it's an ongoing process during the mission.
How do you see the public and private collaboration to further promote space exploration?
Well, I think, it's great that the private space industry is pushing everyone to do more in space. Certainly, it's giving a lot of energy to the public. It's helping people understand that, we still exist. There was a rumor going around for a while that NASA didn't exist anymore. I don't know. The internet is an amazing place. NASA does exist. We've never not existed since our inception. Yeah. But, I think sometimes, it can really help us when we have other people outside of our regular community who are pushing for some of the same things, like trying to get more missions to space and even getting more people into space.
Yeah, and of course, more powerful rockets that are being developed can enable faster missions to the outer planets, which are always top on the list of things that NASA wants to explore next. So it's very important, this interplay between public and private.
By the way, it usually, according to what I've read, takes between 3 almost to 8 months to get to Mars. You're suggesting with more power, it could take a lot less time, right, Tony?
Yeah, that's certainly true. Certainly for the rover missions, the rockets we've been using, the Atlas V, have been perfect for those uses. But you can imagine missions with much more mass requiring more powerful rockets.
If you asked anybody on the street for one question about Mars, the only question I think you'd get almost every single time is, well, is there evidence of life on Mars? I know you touched on it briefly at the top, but let's talk specifically. Is there actual something that you get excited about? Do you believe there is real evidence, concrete evidence of life on Mars?
See, I get this question all the time, and I think there's 3 possible answers: yes, no, or I don't know. And I don't know is a really valid answer, even though no one likes that answer. But I don't know the answer to that yet. I think that it's very likely, or possible, I shouldn't say like, it's very possible because of what we've seen. Mars was this habitable world for millions of years. So the next question is, was it inhabited? And we are doing the research to find out. But of course, if you make a big claim, you need to have big proof to support that claim. And so right now we have these tantalizing clues about organics and the possibilities of life, but it's not a big enough proof that would say to me, okay, this is absolutely the case. And I want to tell you, I would be the first to tell everyone if we actually found, irrefutable proof. And I hope that we do. But at this moment, we have to be very careful in our research just to make sure that we don't make premature claims, right? Because I think it really undercuts scientists in general if we overhype what we know and what we don't know. And so, I think we are trying to do that work. I think it's really exciting, and I think we should ask these questions. And we are, it's possible that there was life on Mars, and so I think it's worth asking the question. And so, hopefully, we'll be able to have more of an answer to that, relatively soon. It's certainly within our lifetimes.
The $100,000 question is when? When do you think we'll have a crew mission that goes to Mars?
Well, I think it's something that's on NASA's radar, but I think they're focusing on a mission to the moon first to sort of build some of the technologies that would be used for a Mars mission. So it'll be, I would imagine, a couple of decades. But I'm not the expert in that area, but I'm always advocating for more robotic missions to Mars. I would love to see more of that, because it's a great return on investment. But of course, there's nothing
safer.
Yeah, there's nothing quite like having a human on the ground, physically picking up rocks and choosing samples to take, as opposed to a robot. You can't replace that.
Well, yeah, I'll jump in and say, I don't think I'm quite replaceable yet by a robot, although our robotic explorers are really amazing. I do think that, they provide us with so much information, but still, if I had boots on the ground, on Mars, and I could do a geologic survey, we would know a lot more probably than we do now. And that's just because people are really good at synthesizing information.
These rovers are already working there. What's the next generation of rovers, and what do you think they would be capable of doing, or you want them to be doing?
The next generation of rover will be related to the sample return mission, where it'll go and it'll fetch those samples that we're collecting now on Perseverance, and then putting them on a rocket for return back to Earth.
That is the last Mars mission that's actually on the book, so which sounds a little bit crazy, but everything that we've been doing in the Mars program has been leading to sample return. And in fact, Perseverance is that very first step in sample return. So we're already doing that. And so I think that's going to fundamentally change our understanding of Mars and will feed forward into future Mars missions, right? Because we're going to learn so much more. So I don't think that we know what the future missions are going to look like beyond that, just because we don't know the next questions yet, and we will soon, which is exciting.
So Nina, many engineers working at Los Alamos, especially your team, are women, which to me is a great compliment, but I don't believe we have enough women engineers working. What do you think makes Los Alamos such a positive space for women engineers, and what additional work can we do to get more women and young girls involved and interested in STEM?
Well, we have this incredible engineering team, which is, in fact, mostly women. So most of the people who are commanding our instrument are women. Tony is also on the team, so we're not exclusive. But it just happened to be that, the people who were the best suited happened to be women. And so part of the reason this happens is, there's many reasons for it. But I think, once you start having women on your team, they know other women. A lot of women know other technical women. And so it's easier to attract women when you have women on your team already, which I know can be a little bit of a catch-22, right? But, you hire one and more will follow. And it also, I think, at Los Alamos, certainly, Los Alamos has been incredibly supportive of my career in many ways. I could go on about it, but really, truly, I felt like it has been a great place for me to build my career. And so I've been able to encourage other people to come and work for us. I think, Sally Ride once said, "You can't be what you can't see." And so it's really important to have people, all types of people on your team. We're talking about women here, but it could be people from all different backgrounds. It's really important because you don't know who's going to see that and realize they see themselves in that person, and they can do that. It's all it takes is for that confirmation that, of course you can do this. It's funny because I almost didn't become a scientist myself. It took somebody saying to me, well, why don't you? And I was like, what, are you talking to me? And what a crazy thing, right? I come from a very sciencey family, but even I needed one person to just say, you should do that. And so, I think that we don't underestimate when you talk to people, tell them, I see that it could be you. They may never have had anyone tell them that they could be the next scientist, engineer, what have you. It's very simple, I think. And so we can do these two things, increasing, the participation and visibility of different types of people on our team, and also being sure to let young people know this could be you. That kind of confidence, I think, it makes a huge difference. I sometimes forget as a scientist now, I'm a more senior scientist. I think of myself as just a kid, but our students are half my age now. And wow. Like the things that I say to them, it's important. It could change their lives. And so I try to take care to let them know that I believe in them.
This is kind of a playful question, but it's also, I think, something that it touches my heart, because Mars has always been something that's been fascinating to me. If you lived long enough, would it be a big, big priority for you, either of you or both of you, to be on Mars, to go visit Mars, if it could happen? Would that be a dream come true?
For sure, for me, I would want to be able to return to Earth, of course. It's funny.
We want you to.
Once we were doing a shift for ChemCam on Curiosity, and we were sitting around waiting for the next process to begin, and it came to be known that half of the people in the room had applied to be astronauts. So wow. A lot of people, a lot of our team members are interested in the human spaceflight element of it, and I think, I'm sure Nina will have some fun answer for that.
Well, I'm one of those people. You can out me now. I have applied to be an astronaut. These places, especially the Gale Crater landing site where Curiosity is, we've spent the last 10 years exploring. I feel like I could lead a guided tour. Like, you want to go on a hike, it's going to be 20 kilometers, but I can point out all the rocks to you. It's a place that feels incredibly familiar. I would love the opportunity to do that. But as Tony said, I'm not willing to give up our beautiful planet and my beautiful life here forever to have that, and I don't think, honestly, that NASA would ever send people one way. It's just a little bit grim, right? So I know there are other organizations that have talked about it. I think I would not accept. I have too much that I love here, and I love our planet. I want to live most of my life here, but I would absolutely love the opportunity to go for a walk in Gale Crater or Jezero Crater.
What do you love about Mars?
I love that Mars feels so familiar, even though it's this alien world. That's the first thing that attracted to me about images from the surface. We've been getting surface data since the late 70s. And every time a new picture shows up, I remember looking at this and I'm like, this is a place that feels familiar. In some ways, it almost looks like New Mexico, right? There are plenty of places in New Mexico that doesn't have a lot of vegetation. And so where you are right now,
where you are as we speak.
That's right. Exactly. That's right. So we actually have a fun game we like to play. We have a little deck of pictures. Is it Mars or is it New Mexico? And it's actually very challenging. To me, the idea, the fact that I can imagine myself taking steps on that planet, that's what really drew me to Mars. It's something I love about it.
Beautiful. Tony?
Yeah, I mean, just seeing the effects of water on the surface, like in Jezero Crater where the Perseverance rover is, seeing how it's so Earth-like is so powerful. I think when you look at imagery from places like Venus, it's just so foreign in comparison. So un-Earth-like that Mars in comparison is just, it's a place that will, I think, always have a special relationship with us because it's so Earth-like.
Beautifully said.
Space is hard, and yet it is these brilliant minds like these two and the dedicated scientists and engineers at NASA that make it look so easy. And the community at large has no idea how much effort, how much teamwork, how much thinking has gone behind that. And that just, is something that we need to admire and recognize their contribution to humanity. And this is so aligned so well for what ASME stands for. So, thank you for sharing your thoughts with ASME today.
It gives me chills just to be able to talk to these wonderful people and these conscientious people and what they're doing, and there are hundreds, maybe thousands behind them as well. We shouldn't forget to mention that. Nina and Tony, we want to thank you for taking the time to be with us today. That does it for today's episode of ASME's Unconventional Engineering. Special thanks again to my co-host, ASME Executive Director and CEO Tom Costabile. And thanks also to all of you listening in. We want to hear from you, and we want to know what you think. And we love your suggestions, by the way, for potential future topics and guests. So reach out to anyone on Conventional Engineering Productions team, that production team, or send your email directly to media@asme.org. And to become an ASME member, please log on to asme.org, or to donate to the ASME Foundation, go to asmefoundation.org. For ASME, I'm Roy Firestone. Have a great day, everybody.